Hi and welcome to John's Maths book. In this video we're going to be looking at using Cramer's rule to solve a 3 by 3 system of linear equations. Now I've written the equations we're going to solve in the top left. Now to enable us to do that we need to know how to work out the determinant of a 3 by 3 matrix. So I've written a matrix A, which is a 3 by 3 matrix, and how do we work out its determinant? So its determinant is denoted with A in the middle of 2 bars, and we need to do the following computation. So A multiplied by E times I minus F times H minus B times D times I minus F times G plus C times D times H minus E times G. So now the first thing we have to do is work out the determinant of the coefficient matrix. So the coefficient matrix is the matrix of coefficients of the linear equations. So we have the x coefficients of 1, 3, and 1. The y coefficients of 1, minus 2, 3. And the z coefficients of minus 1, 1, and minus 2. So we need to find the determinant. So we'll apply the rules we've just looked at and work it out. So we have 1 times minus 2 times minus 2 is 4, minus 1 times 3 is 3. And we have minus 1 multiplied into 3 times minus 2 is minus 6. And 1 times 1, we have minus 1 times 1 is minus 1. And then we have a minus 1 multiplied by 3 times 3 is 9. And minus 2 times 1 is minus 2. So that becomes plus 2. So if we work that out, we get 4 minus 3 is 1. Multiplied by 1 leaves 1. The minus 6 minus 1 is minus 7. Multiplied by minus 1 is plus 7. And we have 9 plus 2, which is 11, minus 1 times minus 1, which is minus 11. So we have 1 plus 7 is 8, minus 11 leaves minus 3. So minus 3 is the determinant of the coefficient matrix. So let's calculate the determinant of the X matrix now. So let's write the X matrix in first. So the X matrix, we need to replace the X coefficients with the answer values, which are to the right of the equal sign. So the answer values are 6, minus 5, and 14. And we leave the Y coefficients the same. So we have 1, minus 2, and 3. And we leave the Z coefficients the same, minus 1, 1, and minus 2. So now we multiply it out as we did before. So we have 6 multiplied by, so minus 2 times minus 2 is plus 4. And 1 times 3 is 3, so minus 3. Then we have minus 1 multiplied by, so minus 5 times minus 2 is plus 10, so that's 10. And we have minus 1, sorry, we have 1 multiplied by 14, and it's a negative 1 times 14, so that becomes minus 14. And then we have minus 1 times and it's minus 5 times 3, which is minus 15, and we have a minus, and then a minus 2 times 14. That becomes a plus 28. So 4 minus 3 is 1, multiplied by 6 is 6. 10 minus 14 is minus 4, times minus 1 gives 4. And minus 15 plus 28. The minus 15 plus 28 is 13, times minus 1, minus 13. So 6 plus 4 minus 13 equals minus 3 for the determinant of x. And now we need the y matrix, so we replace the y coefficients with the answer values on the right hand side of the equal sign. So we first of all we'll write in the x coefficients of 1, 3 and 1. So the answer values are 6, minus 5 and 14. 6, minus 5 and 14. And the z coefficients are minus 1, 1 and minus 2. So we calculate the determinant in the following way. So we have 1 multiplied by, so minus 5 times minus 2 is 10. And 1 times 14 is 14, so it's minus 14. And then we have minus 6 times 3 times minus 2 is minus 6. And 1 times 1 is 1. It becomes minus 1. And then we have a minus 1 multiplied by 3 times 14 is 42. Minus, so it's a minus 5 times 1. So it becomes a plus 5. So 10 minus 14 is minus 4. Multiplied by 1 equal to minus 4. So minus 6 minus 1 is minus 7. So times minus 6 becomes plus 42. So 42 plus 5 is 47. Multiplied by minus 1 is minus 47. So we have minus 4 plus 42 minus 47 equals minus 9. And then finally, we have to write in the Z matrix and calculate its determinants. So we need to replace the Z coefficients with the answer values. So first of all, we put in the X coefficients of 1, 3, and 1, and the Y coefficients of 1, minus 2, and 3. And then we put in the answer values 6, minus 5, and 14. So calculating its determinant, we multiply out 1 into, so minus 2 times 14 gives minus 28. And that's minus 5 times 3, which gives minus 15. So minus 15 becomes plus 15. Then we have minus 1 times 3 times 14 is 42, and minus 5 times 1 is minus 5, so it's minus 5, so it's plus 5. And then we have a plus 6 times 3 times 3 is 9. Then we have a minus 2 times 1, which becomes a plus 2. So working this out, minus 28 plus 15 is minus 13 times 1 is minus 13. 42 plus 5 is 47 times minus 1 is minus 47. And 9 plus 2 is 11. Multiplied by 6 is 66. Plus 66. So we have minus 13 and minus 47 give minus 60, and then plus 66 equals 6. So to calculate x, y, and z, we divide, first of all, the determinant of x by the determinant of the coefficients. The determinant of x we calculated as minus 3, and the determinant of the coefficient matrix was also minus 3. The minus 3 divided by minus 3 leaves 1. So for y, we need the determinant of y and the determinant of the coefficient matrix. The determinant of y we calculated as minus 9 divided by determinant of the coefficient matrix, which is minus 3. So minus 9 divided by minus 3 is 3. And then for z, the determinant of z, which is 6, divided by the determinant of the coefficient matrix, which is minus 3. So z is equal to 6 divided by minus 3, which is minus 2. That concludes this video on using Cramer's rule to solve a 3x3 system of linear equations. If you like the video, then please hit the subscribe button, and also tell me how much you like the videos in the comments section. It'll really help the channel, and it will enable me to make more videos like these. So until next time, bye for now.